Okay, so today we are going to talk about equivalent forms of exponential equations and expressions. So for example, if we have a car that's losing value according to a yearly formula, we want to figure out how much is the car going to be worth tomorrow on a day-to-day formula. So you don't have to write this down. I just want you to think we're going to eventually convert a yearly formula to a daily one. So in this lesson, we're going to learn how to change exponential models to reveal hidden information by using different properties of exponents. Okay, again, don't write this down. I just want to do a quick review. When you have an exponential equation, this 3 here, which is in the spot of A, is your initial value. 2, which is in the place of B, is your growth factor, how much you'll increase or decrease by. And the x in the exponent is the number of times. So when x is 0, we plug in 0. When x is 1, we plugged in 1. When x is 2, you have 2 2's, because that's 2 squared. When x is 3, that's 2 to the third. And so on, they have down to 2 to the fifth. On a graph, we can see we have the horizontal asymptote on y equals 0. We have the y-intercept here at 3, and it's in that nice curved shape, increasing rapidly. So now turn to page 31 in your packet. We'll pause the video here for you to find it. And using what we learned yesterday, let's do number 1. If you start an experiment with 2,000 bacteria, so that's going to be our A value, and 1 hour later there are 2,880 bacteria, let's write an exponential model. So that's the coordinates 0, 2,000, and 1, 2,800. So I prefer the chart form. So we know that for an exponential model, we're going to multiply by the value of b. So let's figure out b is going to be 2,880 divided by 2,000. You may use a calculator for this, and we get 1.44. We have to define our variables when writing an equation. So I'm going to use capital B for the number of bacteria, and T is going to be time in hours. It's really important that you include the units here for your time. So B equals the initial value, 1.44 to the T. So if I was going to fill in the box here, here's my equation. And what that tells us is the 1.44 is going to be able to tell us the percent rate that our bacteria is increasing. I know it's increasing because we have 2,000 to 2,880, so it's going up. Now, when we have an exponential equation with the rate, we can have a standard equation where it's 1 plus the percent rate to the time. A is your amount, so that's like my bacteria. P is the initial amount, here the 2,000. So then this is 1 plus the percent rate as a decimal. So if I take the 1 plus the percent rate and set it equal to the 1.4, I can solve for my percent. So that is 44% as a rate that is increasing per hour. Now, how do we want to change it to represent per minute? Well, since T we defined before is time in hours, how many minutes are in an hour? That's 60 minutes. So what we can do And here it says A, but we used B on the page before, so I'm going to make this a B. So B equals 2,000, 1.44, and I want to change T to be time in minutes. So now I'm going to raise the 1.44 to 1 over 60, and then change the T to be 60T. If I use my property of exponents, if I multiplied these back together, the multiplied numerators and denominators, I still get that T. So I haven't changed the value of the exponent because I included both this fraction and the 60. So now I can recalculate this 1.44 to the 1/60th. Again, use your calculator. And when you type that in your calculator, be very careful. You must put parentheses around the exponent of 1 divided by 60. Start writing this over, sorry. And because we're using a percent, what I'm going to do is make sure you use enough decimals. So I'm going to take this out to here. So now our equation is by the minute. And we can put time in minutes. But now what if it said, well, what is that percent rate? So 1 plus R equals that long decimal. We'll subtract 1 from both sides. And here's why we needed so many decimal places. When you write your decimal as a percent, we're going to move the decimal over 2. So this is 0.6096%. Okay, so here's number 2. We have a new car, and it's going to decrease in value by 10%. So when it's decreasing, we're going to do 1 minus the rate to the time. So let's write a model. So the amount the car is worth started at 22,000, 1 minus 0.1 to the t, where A is the value of the car and T is time in years. And I can see it each year here. So simplifying that, 1 minus 0.1 is 0.9 to the t. So how can we change it to per day? Okay, so how many days in a year? It's 365. So we're going to take our equation and I'm going to make the exponent on the 0.9 1 over 365. And then I'm going to make the exponent 365t. To simplify it, we need to find the decimal for 0.9 to the 1 over 365. And that is 0.99971138. Well, the question specifically says about the percent loss per day. So I know that 1 minus R has to equal 0.999711138. And then solving that, I get negative R equals negative. And your calculator might give you a funny looking answer of, mine did negative 2.886172898. e negative 4. And what this e negative 4 really is scientific notation. So that's times 10 to the negative 4. Because that exponent is negative 4, it's negative, we're going to go 4 decimal spots to the left. 1, 2, so that is negative 0.0002888617. Both sides are negative, so we'll divide by negative 1. So R is 0.0002888617. But now changing it to a percent, that is 0.02886% each day, because we converted it to the days. All right, so we have another question in here, and we squeeze it in. What is the asymptote, and what does it suggest? Well, it's an exponential equation, and here's my A value, here's my B value. There's been no vertical shift, so the asymptote is the vertical line y equals 0, and in this case it would be A equals 0 because I'm using A in the place of y. What does it suggest? The vertical asymptote of 0 means the car value will never reach 0 or be negative. Okay, so now we have a number of fruit lies in an experiment, and they can be modeled by that equation, where T is the number of weeks. What is the percent rate growth per day? Okay, how many days are in a week? 7. So we're going to take our equation, convert it to days. Now I need to do 1.2 to the 1/7. Then we have to figure out our percent. So I'm going to say 1 plus R because they told us its growth equals 1.026. That's all the decimal places. Subtract 1. Change it to a percent, and that is 2.63881% each day. Now down here we have a common misunderstanding. The common misunderstanding is to take the 20% from the 1.2, because if 1 plus R equals 1.2, R would equal 0.2, which is 20%. And that was weekly. And just divide that by 7 to get 2.9%. Well, 2.9 is not the same as 2.63881, or they rounded to 2.64. So this is a big no-no. It's the big red X. Do not do that. You have to convert the entire equation by using a property of exponents, the fraction with your number, and then the whole number with the exponent. Okay, so now this page actually starts your homework. So we'll stop the video here and you can do your homework. Make sure to check all your answers on Edline.